Okay, good afternoon. Today we are reviewing that CO27. I can find a percent change, and I'm just recording as we're going through how we worked out each of our problems. So if we need to go back to it, we can make sure that we understand how to do it. So we reviewed the bottom of this page in class right now. So I'm just going to review one of them real quick with us for my friends at home. Remember, if we look at this one, we would do 180 minus 70 divided by 180 for my original on the bottom. 180 minus 70 is 110 divided by 180. And looking at our test for next week, I discovered we can use calculators on this. So it's just really easy. You just put in your calculator 110 divided by 180 would give us 0.61, which is that 61%. So this is going to really help us on this next page when we are working with these millions numbers. So yesterday we did that A together, and it was tricky doing long division with those millions. So let's check our work, and we're going to do it with the calculator. So for A, what is the problem that I would write? What is the equation that I need to write out? Emily.
Switch that. 2, 3, 4, 9, 1, 8, 6, 6. Minus 5, 3, 0, 4.
Yeah, because we always put the bigger number first when we are subtracting like this. And what are we going to put as our denominator?
5, 3, 0, 8, 3.
The original number, which is 5,308,483. So I'm going to do my subtraction. I'm going to do it on the calculator so I don't make those simple mistakes. 191,876 minus 530,8483. Oh, and somehow I got messed up with that. Press the wrong button. 876 minus 530,8483. So did we get 23,231,9? No, it is. My calculator is not able to do that. What did you get subtracting wise? So I don't have it written in the book, and my calculator is
It's 23,191.
Say that again.
23,191. 2876.
But if we're doing 23 million minus 5 million, I'm not going to get 23,191.
No, then it goes 7,876.
So let's work it out this way, because the calculator. What was that, Gus?
It's 17,883,395.
17,883 what?
395.
395.
That is not what I wrote. 393.
393? Well, there's a 3 right here. 6 minus 3. So you might have written a little bit sloppy. That's why we need to write so we can read it. So then we divide that by the original. So we would have 17883,393 divided by 530,8483 equals 'That is not. Oh my heart. My calculator skills are not doing so great right now.
That's why.
We did this one together in class.
Yeah, but we don't know for sure.
So it was 337%.
That's what I did.
And I keep hitting the wrong button. Wow, it is only a Tuesday and I am having massive issues. It is a Friday in my head. You are correct.
Yes, it is. It's Tuesday. It's Friday.
There, now I did my math correctly. So we end up getting 3.37, which turns into 337%. And when we're working with these big numbers, if you mistakenly put in the wrong number, it's super easy to make a mistake. So, even though we get to use the calculator, still super easy to make those mistakes. So make sure you go slow. I am going too fast up here and I punched in the number incorrectly. And I knew I got the wrong number because it wasn't a decimal like that. So I knew I did something wrong. So when you're doing your math, just like I've talked with a few of us with our math packets, does your answer logically make sense? If there's 132 seats on the plane, would you logically have 300 and some passengers? Okay, it doesn't make sense. So somewhere you went wrong. So that's what just happened with me when I was punching in the numbers, and all of a sudden I got an answer that was like 11,000 something. And I went, well, that doesn't make sense. I did my math wrong. Okay, so always make sure you do your math correctly. So for B, we had 1850 and 1900. So I'm going to start with my big number, 76,212,168. I'm going to divide that by subtract that by the smaller number, 23,191,876. And then my original was 1850, so I'm dividing it by the 23,191,876. For our answer, if you do that math correctly, you get 229%. Shh. Emmett.
I got 228%. Would that be all right?
That means you didn't round correctly. Okay, so
Please pardon this interruption. Would all boys choir members please report to the music room? Boys choir, you are meeting in the music room. Thank you.
Do we have any boys choir in here? Okay. So the question with being off by 1 means you're not rounding the right way. So yep, we're going to be looking for the exact answer. Can you wait till we're done? Priya?
Why do you round it?
Because you can't just cut it off. So what is 76 minus the 23? What million do I get? Wait, I'm sorry, say that louder.
53,020,292. Yeah, 530,20292. That's pretty good.
What was the hundreds?
292.
292?
Yeah.
So when we put those numbers into our calculator, 53,020,292 divided by 23,191,876, we get 2.286157963. We want to go to the hundreds place because it's a percent. Percentages go to the hundreds. So in order to cut it off and not put all of those into our percent, you have to round. Like that's the rule. You can't just drop numbers off. Okay? When we want to drop those numbers off, you have to round it. You can't just stop. It's just a math rule that we have to live by. Okay? So that 6 would make that round up to the 9. So we know it's 229%. And it's just, we have to do proper math. It would be like talking in a grammatically incorrect sentence. Would Mrs. Gregory allow that? No. Would she allow you to type something like, oh, now I can't even think of a grammatically incorrect. Me go to the store. That's how much it would hurt my ears. Think about how that hurts your ears. Me go to store. Friends. It does not sound right. It's incorrect. Same thing if we don't round correctly. It's just wrong. Okay? We don't want to be doing incorrect math, like we don't want to do incorrect grammar. All right, for C, we did 1900 and 1950. Okay, one of you come over here. I am being way too distracted. Ladies, you choose. One of you move. Quickly. Thank you. So 1900 and 1950. So we have 150,697,361 minus 76,212,168 divided by the original 1900 was the 76,212,168. You do that math, subtract it correctly, divide correctly, round your decimals correctly, and we get 98%.
Oh yes.
This was 337%. Is there anybody who's not sure where they went wrong? Tegan. Okay, so what did you get for 150 million, whatever, minus the 76 million?
I got, probably not, because I have like multiple different things, but it is the 53.
So what did other people get when we subtracted?
Oh, 53. Yeah, 53.
53, 02, 02. What comes after this two?
0202992.
Like that?
Yeah.
Is that what other people got? Then you divide that by the 76,212,168. So try it again on your calculator, Tegan, while I try it on mine. Sometimes it could be easy about just putting in a number incorrectly.
I don't know how I got the answer I got.
Maybe I wrote this down wrong. Is it 53,020,292? Using these numbers?
Yeah. Wait, let me see.
And I must have.
Yeah. That's what I got.
There. Well, I'm getting different. So let's do 150,697,361 minus 76,212,168 equals. This is not correct. It should be 7448519.
Oh, yeah. I had another one up here that.
Okay, divide that by 76,212,168, and you get 0.977. Can you wait till we're done? So it could have been that you put in a number incorrectly, or you just missed it when you were rounding it. You rounded incorrectly. Okay? But we want to make sure that we're subtracting correctly.
I forgot to add, so I put 977.
Okay. Yep, so simple mistakes happen. You had the right number up here. I think you might have punched it into your calculator wrong.
Yeah.
Instead of putting a 0, you put a 1. I mean, things like that happen easily. So when we're doing our test next week, when we're using our calculator, especially with the big numbers, super easy to make simple mistakes. Go through and do it again and see if you get the same answer. That's how we check our work. So let's look at D, 1950 to 2000. So that's 281,421,906 minus 150,697,361 divided by our original was 150,697,361. We do that math and we get 87%.
I think I rounded because I got 88%.
Okay.
Oh, yeah.
So if we have 281,421,906 minus 150,697,361, I get 130,724,545. Is that what you got, Tatum?
Yeah.
Divide that by 150,697,361, and I get 0.867.
I might have got it.
So you might have seen the 7 and gotten confused and accidentally rounded the 7 instead of the 6. It happens, especially when we're working with big numbers. Super easy to get, it all starts swirling in our head and we accidentally round incorrectly. So that's why I said, go back on the test. You're going to go back and do the math a second time to make sure you didn't make one of those simple math mistakes. Because we're understanding the equation, we just need to be able to use it. So now let's look at our questions. Between which years is the percent of increase of the U.S. population the greatest? So between which 2 years? James.
1900.
So this is the greatest amount of percent increase we had? Look at our percentages we had for each of those years.
Oh, I was looking at the numbers, like, seeing, like, what. Yeah, that's what I did. It says to me.
But you have to read the question. Between which years is the percent of increase? They're not looking at when did the population increase the most. When was the percent of increase the most? Mario?
Between 1800 and 1850.
So you have to make sure you're reading the question correctly. Percent of increase, we're looking at our biggest percentage that we had showing. Next one, between which years is the percent of increase of the U.S. population the least? So if you wrote it wrong, if you were looking at it wrong, fix it. Audrey.
1950 and 2000.
Yep. This is our smallest increase that we had between 1950 to 2000. That percent of increase is a lot smaller. Emmett.
Why did you do 1,800 to 1,805?
Because it's a Friday in my head.
It's a Friday night. You have the.
Okay. Got a little dysgraphia going on in my head. It happens. Just when you flip numbers. Chance. Okay, does a smaller percent of increase mean the population increased by less people? What do you think, Chance?
Well, I said not necessarily because it depends how big the first number is compared to the second.
That's exactly it. It depends. It depends on what your original number was. Okay, so when we look at this, 5,000 or 5 million to 23 million is not as big of an increase as 150 million to 281 million. right? There's less people, but we started with such a smaller number that percent of increase was so much bigger here. So it really depends on what your original number is. All right, let me scroll up. Do we have any questions on this, or does this page make sense? Is it making sense? Show me your thumbs. I saw Emily's thumb. Let me see everybody else's thumbs. Where are we at? Emily, is that sideways or up? Okay. Making more sense?
Yeah. I think it makes sense from before. Still.
All right, so let's look at the bottom. Using values adjusted for inflation, the U.S. median household income in 1970 was $42,934. In 2021, it was $79,900. Find the percent of increase from 1970 to 2021. For the record, median worldwide household income in 2013 was about $10,000. Wow. So on average, our median in the United States is a lot higher than what it is in the world, which is a good thing. So do we need to know what's in parentheses? Do we need to know that for our math problem? No, that was extra information that he threw in. Interesting fact, we don't need it for our math problem. So we want to know the percent of increase from 1970 to 2021. So we're going to do 79,900 minus 42,934 divided by our original. I want to make sure I'm using the same numbers.
Why don't you just do it over the thing? Oh, it's not even close.
So, did you set your problem up the same way?
I set it up the same way.
You set it up. So then we have 79,900 minus 42,934. So you should get 36,966 divided by 42,934.
My subtraction was wrong.
And you would get, if you followed through, when we show our work, which you have to do, you would write this problem down. Then you would write this problem down so we know what math you're doing. You punch it into your calculator and we get 0.860. So we know it's 86%. But don't just write down the original problem and then put down what percent you get on the calculator. Write down what that subtraction was so you know if you went wrong when you do it the second time to check your work. Emily.
So I got 36,966 for the subtraction problem. And then I did divide. I did 42,934 divided by.
You got what?
1.6.
So did you take the 42,000 and divide it by the 36? Yeah. It's super easy to make those kind of mistakes. So that's why we do it a second time to check our work. So you're supposed to take the top and divide it by the bottom. So you always take the top and divide by the bottom. When we have our test score and you get 37 out of 40 correct, you want to know your test percentage, you take the top, what you got, and divide it by how many total there were. So you always take your numerator divided by the denominator. So you put in the numerator first, then divide by the denominator. Any other questions on this one? Okay, time for review. What is 90% of 30? What did you guys get?
27.
Yes.
How did we get 27%? Tegan.
I didn't do it like the right way, but I just multiplied 90 and 30 and then but I didn't jump. What?
Explain that to me one more time, Tegan.
I multiplied 90 and 30, and then that was 2,700.
And then you put in the decimal.
Yeah.
Yeah, so that is the right way.
Okay.
Yep.
It's what?
James?
That's basically the same as mine, but I put it into an equation.
So tell me the equation you used.
I did. Whole is whole 30 times the percentage, which is 0.90, equals part.
So we have the part equals the whole times the percent. So you multiplied your whole by the percent and then you put in your decimal. So it's still the right way. You just worked with your decimal at the end instead of at the beginning. Yes.
27 would be the number, not the percent, right?
Yes, you are correct. 27 is the number. So our part equals 27.
Oh, yeah.
I accidentally put the percentage on there. It's Friday. Chance.
I did 30 times 0.9.
Yep. So I just did put in my 0 there. Yep. Okay, next one. Increase 40 by 35%. So 40 is our whole. Right? And we want to increase by 35%. We have to find what that part we're going to increase by and add it to the 40. So what is the part that we're going to increase it by? Emily? So 40 times 0.35. That part isn't going to be 10. If we multiply 40 by 0.35, what do we get? Audrey?
I got 14.
Yeah. That equals 14. So our part equals 14. We have to add that to the 40 because we want to increase the 40 by that much. So 40 plus 14 gives me 54. Decrease 90 by 40%. So we're going to take our whole of 90, multiply it by our percent to equal the part. So 90 times 0.4 equals what? 36, because you forgot your decimal.
Oh, yeah.
So is my answer 36? Gobble, gobble, turkeys. These are your Tuesday afternoon announcements. Reminder, there is no fire after school today. We have the following students that need to pick something up in the office. Ellie Broderick, Nolan Peterson, Connor Oswego, Caitlin DeMonto, Nathan Fraser, Jonah Tung, Wyatt Miller, Will Tipton, Damian Seibert, Noah Seibert, Gavin Reek, Tegan Miller, and Vince Lenmark. We hope you have a beautiful Thanksgiving weekend for your families. Make sure to say thank you to the friends and family that you see. Thank them for the food that they prepare. Thank them for the love and support that they give. And thank your teacher on your way out of school today. God bless you and love truly.
Okay, so just wait till I'm done here and then you guys can pick up what you need to pick up. So if we got 36 as our part, what is the answer to my question? Decrease 90 by 40%. Yes.
54, but you have to go 90 minus 36.
We had to subtract, we had to decrease 90 by the part of 36. So 90 minus 36 gives us the 54. 60 is 20% of what number? 60 is our part of what number? We have our 20% times our whole. So that's 0.2. So I need to divide by 0.2.
Oh.
So my whole is going to equal what, Emmett?
300.
So 60 divided by 0.2 is 300. Chance? Sure.
I figured out as So I divided this by 5 to get to the 20. So divide by 5, so I multiply this by 5, and then I got 300 to divide.
So, what I'm seeing is you multiplied by 20. Sorry, yeah, multiply by 20 because multiply by 20, divide by 20 cancels out. So you multiply by 20 over here. So then you simplified it down to get that 5 on the bottom. So then you multiply it by 5. Yeah. It's a little bit more complicated, but it works as long as you're getting the right answer, however you do to get it. So with that, I'm going to say goodbye to my friends that are listening at home. We hope you are doing well, and we hope you have a very wonderful Thanksgiving. We hope to see you soon. Bye-bye.